Sophia.
I'm Georgia.
And this is our physics final. Yay!
Our topic is Newton's second law.
Newton's second law states that the acceleration depends on the net force and the mass of an object. The equation for Newton's second law is F equals ma, and F stands for force, m stands for mass, and a stands for acceleration. So for our first experiment, we used a friction block and a hanging mass and a pulley to calculate the acceleration of the system. So for our experiment, we found the mass of the block to be 126 grams or 0.126 kilograms, and the mass of the hanging mass to be 50 grams or 0.05 kilograms. And the block went 0.5 meters in 0.96 seconds. And the coefficient of friction for the system was 0.25, which we found using the typical coefficient of friction for felt on plastic. And those are the free body diagrams for the block and the hanging mass. As you can see, the normal force and the mass of the block cancel out, and the two forces of tension also cancel out. And ultimately, we're solving for acceleration. So using Newton's second law, we convert force equals mass times acceleration to acceleration equals force over mass. And ultimately, the sum of the forces is the mass of the hanging mass or the weight of the hanging mass, and then the force of friction over the sum of the two masses. And that's the final equation, but we do have to solve for some stuff first. So first we converted the masses of the block and the hanging mass to newtons by multiplying them both by 9.81. And next we have to find the force of friction as shown in the final equation. So the force of friction is mu times the normal force. And as we can see up there, the normal force is equal to the weight of the block. So we just multiplied the coefficient of friction to the weight of the block and got 0.31 newtons. And then we just plugged all of that into our equation that we found earlier and got 1.03 meters per second squared for the acceleration. For our second experiment, we dropped a tennis ball to calculate the acceleration of the tennis ball using the force and the mass. So we found the mass of the tennis ball to be 56 grams or 0.056 kilograms. And we dropped the tennis ball from a height of 1 meter. And it took 0.71 seconds for the tennis ball to hit the ground. So next we drew a free body diagram of the tennis ball, and the only force acting on the tennis ball would be gravity. Next we found acceleration using Newton's second law. So we took Newton's second law equation, the sum of forces equals mass times acceleration, and we changed it to become the acceleration equals the sum of forces over mass. And yeah, so the sum of forces equals mass times gravity, since that's the only force acting on the object. So for that, we got 0.549 newtons by multiplying the mass times gravity. And we already know the mass to be 0.056, so then we just plug those two numbers into the equation, and we got 9.8 meters per second squared to be the acceleration of the tennis ball. For our third experiment, we released two different carts down a ramp, one with a mass on the cart and the other without a mass on the cart, to see if mass would change the acceleration of the carts according to Newton's second law. So first we drew the free body diagrams for the two carts, and they are exactly the same. They both have a force of friction, a normal force, and then weight as a force. We found the mass of the cart without the extra mass on top to be 0.2697 kilograms, and the one with the mass to be 0.5197 kilograms. And both of the carts went down a ramp with an incline of 25 degrees and a coefficient of friction of 0.21. So next we solve for acceleration. So we took the Newton's second law equation, the sum of forces equals mass times acceleration, and we reworked it to be acceleration equals the sum of forces over mass. Then we found the sum of forces to be mg sine theta minus mu mg cosine theta over the mass, and one of the masses cancels out in the equation, so it turns out to be gravity sine theta minus mu mg cosine theta. And we already have all of those numbers, so we just plug them all in for the car without the mass and the car with the mass. And we found that the cart without the extra mass on top had an acceleration of 3.64 meters per second squared. And then we did the same for the car with the mass, just plugging in all the numbers. And we found that acceleration to be 3.175 meters per second squared. So as you can tell by our experiment, the mass of the object does matter and does affect the acceleration of the object, according to Newton's second law.